great. We were talking briefly yesterday about this. We're going to see how our equations might or might not show up today. We'll see if they show up. We talked about a 6% grade. We talked, I believe, about College Way yesterday. College Way. And the grade on College Way. The grade on College Way. And what was the grade on College Way? I think we discovered, yes, it was also 6%. So what did we say that meant? When you have a 6%, two lights. Like the rest of them. No, almost. Does that go like that? Decent. 6%. Brittany, help me.
So you're going, it doesn't matter the units, they have to be the same. 6 for every 100.
Love it. 6 what for every 100 what?
6 for every 100 feet or 6 miles.
Good. 6 feet for every 100 feet. 6 feet of what for every 100 feet of what?
Rise over.
What about the road?
Oh,
Sorry, stop yelling.
Rise.
Rise over run. Okay, so there's a definition that we kind of arrived at yesterday. And it's not so much a definition as a revisiting. I put a link on your schedule page to the topic of grade. I have the spreadsheet linked. I think I have the, if I don't have the spreadsheet link, I'll link it today. There's not much in it other than pictures and some percentages, unfortunately, so it's not very descriptive. So I linked in a hyperlink that I found online. I just decided to type in, I was like, let's just see what's out there for grade. So I typed in grade of road and enter. The first hit I got was a Wikipedia page, which was great. The second was a Yahoo Ask, one of those Ask Questions, Ask Bill, or Ask.coms. It was great. It said, could you tell me what the grade of a road is? And then there's a 3 or 4 paragraph answer. The first paragraph was right. The next 3 paragraphs were completely wrong. But it was the upvoted solution, which means everybody thought it was correct. Correct enough, I guess because it was long, that it needed to be upvoted. It's like, wow, that's so interesting. So if you look at the schedule page from Monday, I mentioned that on there. First paragraph is fine, other paragraphs are all wrong. Next week I'll have a quiz where that you can find, you have to tell me in these paragraphs what is wrong about it and fix it and make it right. Which I have students do often. Problem with the internet, anybody can post anything. The best part about the internet, anybody can post anything. It's full of stuff. Some of the stuff is garbage. Wikipedia, I think it's a great resource. It's also full of little holes, some of which I've patched myself, colleagues have patched. You gotta be careful finding stuff online. I try to keep you guys as safe as I can by only giving you stuff that's mathematically correct, but then you find something like that that's like half correct and half not. Grade, by definition, the simplest possible definition, is just the amount that you rise over the amount that you run. It's the amount that you rise over the amount that you run. What's interesting about that is, on a road, you never see the rise and the run. When you're driving along a tilted road, up or down, you don't see either the rise nor the run. You see the hypotenuse, I believe is what Randall or Aaron told us yesterday, the goofy diagonal part of the road. So imagine, if you will, the College Way, let's say this is College Way, which I know it seems like when it's covered in ice. You're driving on the diagonal part, the hypotenuse, right? If I put that little box right there, is that okay? Little box, little right angle. Okay, good. So here's your hypotenuse. This is where your car goes. There's you waving out of it. The rise and the run are what makes the tilt. Rise, run are what makes the tilt. So using Brittany's awesome example of it doesn't matter what unit, and I love that so much because that ties directly into next week. We go outside and measure some trees using geometry and a little teeny bit of algebra. It doesn't matter what unit. It doesn't matter what unit. As a matter of fact, sometimes you want to think logically about what unit you should use. The first, I think, example you said was 6 feet over 100 feet. So if we were to come out here, and drop a, so we've now got a little mini rise and mini run. I call that mini rise, mini run. That's only because I dropped the bigger one over here. This could obviously extend out, correct? And make a larger rise and a larger run. So you got a little mini rise, a little mini run. Suppose this is 6 feet. That would make this be 100 feet. 6 divided by 100 is 6%. You gotta remember what percent means per 100. So you can see that different ways, right? You can see it as 6%. I think you guys told me last time that 6 over 100 is fantastic. I know that sometimes we see fractions like that because we've been brought up in pre-algebra classes. You must reduce. Okay. 3/50ths, that's fine as well. I like to keep the 100 near the bottom whenever I can because it becomes obvious what percentage you're talking about. See it as a decimal? 0.06. Bunch of different ways you can express it. The signs are always going to have a percent sign. So 6%. I think we're just used to that as Americans. So if you go 6 feet to 100 feet, all good. All good. You come out here, suppose this is 60 feet. Right here. That means that the ran has to be 100. Oh, this was 6 inches. Did a Spinal Tap reference there, didn't I? 6 inches, 60 feet, 100 feet. It doesn't matter what unit you use. You could use meters, you could use centimeters, you can use miles, use anything you want, as long as you're consistent with both of them. Do you remember why you had to be consistent with both? Like why you can't mix and match like kilometers and miles? Kelly, go ahead.
6% grade wouldn't, at 60 feet, wouldn't that be 1,000 feet of run?
Thank you. Or change that to 6. Either way. Thank you, brother. Thank you for catching the math mistake. Much appreciated. Why is it important, though, to keep the units consistent? Go ahead, Brittany. Remember that argument? You have to make sure the units can be gotten rid of. So whatever unit you have in the top, you have to dump that in the bottom. The reason I bring this up is there are so many tracking software programs now available for like cell phones. Folks that are going out and going into the woods or going into the mountains and doing hikes or doing long bike rides, and they'll track your elevation. I'm going to have you guys analyze it soon. If you've already looked at the extra resources page, there's a track in there of a hill repeat workout that I do. And they're great. They kind of look like this at the end of the day, but they mix and match units, which is fine as long as you catch it. For example, the unit on the vertical might be meters, so they might be measuring rise in meters, but they might be measuring run in miles. So you got meters per mile. You can't cancel meters per mile. You have to convert one to be the other. So just be aware of that. Be aware that whatever units here, they have to agree with the units here. Keep that handy as we go through today. Now today it'll be pretty simple. We're going to be measuring grades of COCC's campus. We're going to be using inches for the most part because the things I'm going to have you measuring aren't crazy. I'm going to also use the transit that's out there to measure the diagonal slope of an ADA ramp. But you got to realize, just be consistent with the units. When I was measuring these, I used a clinometer. Any backcountry skiers in here? Anybody use a clinometer before? It's essentially a protractor, but it points down. So it's like a credit card shaped thing with a circle with degrees measured. And then you can tilt it like this and the arrow keeps pointing down. So it starts at 0 at horizontal, which would be 0% grade. 0 rise over whatever run. And then as you start going like this, it starts to tell you what angle you've come through. So once I know the angle, I can convert that to grade. Which brings up the next question. What angle corresponds to a 6% grade? Which angle